Alright, so our final section here dealt with predicate logic in Chapter 8, and you had two homeworks remaining to work with, which was 8.1, Section 1, and 8.2. Now 8.1, the idea was simply to translate the statements from our ordinary language, the way we normally speak, into the symbolic form of predicate logic. And so I gave you 2 through 20 even, so I'm just going to run through these and you can check yourself. Of course, as I mentioned previously, I will be online for the class at 9:30 on Wednesday if there's any specific questions, but for right now we can just go through the answers. So at number 2, it says Nancy is not a sales clerk, and they want you to use S for sales clerk. Again, with predicate logic, you're looking at the predicate to be the capital letter and the subject to be the lowercase letter. So, if sales clerk is S, the lowercase n for Nancy, and it's a negated statement, so it would be tilde S n. Number 4 says Rachel is either a journalist or a newscaster. So we would have journalist, capital J, newscaster, capital N. Rachel would be a lowercase r, and it's an either-or statement. So you would have J, capital J, lowercase r, or capital N, lowercase r. Again, either Rachel is a journalist or Rachel is a newscaster. Number 6. Belgium and France subsidize the arts only if Austria or Germany expand museum holdings. So we want to use capital S for subsidize the arts and lowercase e for expand museum holdings. This one's a little bit trickier because you're dealing with multiple subjects. So essentially we're dealing with a conditional statement here, right? We've got the only if. So remember that with only if, what follows only if is going to be the consequent, which means what becomes first would be the antecedent. So we'll start with the statement Belgium and France subsidize the arts. So that would be in parentheses SB and SF. Okay, so Belgium subsidizes the arts and France subsidizes the arts. And of course it has to be in parentheses because that's showing you that this part is hanging together as the antecedent, whereas after the horseshoe we'll have the consequent, which is also going to be a compound statement. It says Austria or Germany expand museum holdings. So that would be EA or EG. Okay. So Austria expands museum holdings or Germany expands museum holdings. So that would be number 6. Number 8 says some grapes are sour. All right, so now we're dealing with one of those categorical statements. And remember that with the categorical statements, you need the quantifiers. We're going to use G for grapes, S for sour. And because it's a sum R, it's an existential quantifier, which is the backwards E with the X like that. And then GX and SX. So basically, this says for this particular X, this X is both a grape and this X is sour. Okay? So some grapes are sour. This particular X, whatever it is, happens to be both a grape and a sour thing. Number 10, some holidays are not relaxing. So we're dealing basically with an O-type statement here. So again, it's an existential claim. Some are not. So that would be the backwards E with the X again. And this time HX and not Rx. So for this particular x, this x is a holiday, but this x is not relaxing. Okay? So that is the first set here, 2 through 10. I have to erase this now so we can have room to do 12 through 20. So number 12 says Gertrude is not correct only if the Taj Mahal is made of granite. So now we're back to normal statements rather than the categorical type. So we've got an only if, so again that's a conditional. What follows only if is the consequent. And so the first part, the antecedent, says Gertrude is not correct. So that would be tilde, because it's a negation, CG. Okay, so it is not the case that Gertrude is correct. Then, the Taj Mahal is made of granite, GT. Okay, so if it is not the case that Gertrude is correct, then the Taj Mahal is made of granite. 14. Anything that leads to violence is wrong. Okay, so if you remember back when we dealt with categorical logic, we talked about those non-standard quantifiers. So this is what this is. This is basically a categorical statement. What this is really saying is all things that lead to violence are wrong. And so all things, all are, that's a universal claim. So you'd want a universal quantifier, which is just the x, Lx, horseshoe, Wx. So this one basically says, since it's all things for every x, if that x leads to violence, then that x is wrong. 16. Not every smile is genuine. Well, once again, this is a categorical statement that has been put into a non-standard form. So when we say not every, we don't mean every single one. We don't mean none of them. This is going to be a sum. It's going to be an existential claim. So again, you want that existential quantifier, backwards e with the x. And basically what we're saying is some smiles are not genuine. So Sx and tilde Gx. Okay. So for this particular x, this x is a smile, and this x is not genuine. So some smiles are not genuine. 18. There is trouble in River City. Well, again, would that mean that every single bit of trouble in the world is in River City? No. It implies that there is some trouble in River City. So again, we're dealing with a categorical statement. This is basically an I statement. So once again, you want the existential quantifier, the backwards e with the x. And then we want to say that there is some troubles are in River City. So Tx and Rx. So for this particular x, this x is trouble, and this x is in River City. And finally, 20. Any caring mother is vigilant in nurturing. So this one is probably the trickiest of all of the ones that we have in this assignment because it's dealing with a lot of different elements. So we have any caring mother is vigilant in nurturing. Well, again, any implies all of them. So we're dealing with a universal claim. All caring mothers are vigilant in nurturing. So because it's because it's basically an A statement, you need the universal quantifier, which is x. Now, all caring mothers. In this case, to imply caring mother, you'd need Cx and Mx. Okay. So for every x, that x is caring and that x is a mother, then Vx and Nx so for every x, if that x is caring and a mother, then that x is vigilant and nurturing. Okay. So hopefully, with the exception maybe of 20, the rest of those you probably, I hope, got pretty well. Found those to be fairly easy. Again, if you have any questions, you can let me know through email, or you can show up at the 9:30 class on Wednesday morning, and I will do my best to answer those for you. But anyway, those are the answers for 8.1. So now we want to go ahead and move on to 8.2. In section 8.2, we're working proofs, just like we did back in chapter 7 with propositional logic, only this time we're dealing with it with predicate logic. And so we did the first two in class, so we have 3 through 10. So we'll take a look at those right now. So number 3, there's x, ax, then bx. 2 is not bm, therefore ex, not ax. All right. So the first thing to remember when working a proof in predicate logic is the fact that when you have these quantifiers, you have to change them. And so basically what we want to do is to get rid of the quantifier and to replace the x, right? X, y, and z are variables which we're not allowed to use. We need to have a particular instantiation. Now in this particular case, we look at the second premise, not bm, and that tells us that there's a specific letter we're going to want to use, which is the m. So this first line for every x, if x is an a, then x is a b, we're going to make that am, then bm from line 1, and that's what's called a universal instantiation. Okay, universal instantiation because you are changing a universal claim into a particular instant. Now from there, it should be pretty simple. We have lines 2 and 3 that make a modus ponens. And I'll just demonstrate this on the side for you, or a modus tollens. Demonstrate this on the side for you here. So your antecedent is the square. Your consequent is the circle. So bm is the circle. So your modus tollens form, if square, then circle, not circle, therefore not square. So the square is am. So we would derive not am from 2 and 3 through a modus tollens. Now the conclusion that it's asking for looks like this. It's a particular statement with a negative ax. So since what we have down here is not am, we're going to have to do another variation, this time a generalization. And in a generalization, you're going to get rid of the particular instantiation letter and replace it with one of those variables. In this case, we're going to use an x. They want an existential, so we're going to give them an existential. So from line 4, that was a existential generalization. And we have proven number 3 to be valid. All right. Number 4. Line 1 says for every x, ax, then bx. Line 2 says for every y, ay or not by. Therefore, for every x, ax, if and only if bx. Okay, so this one looks maybe a little bit tricky because they've given you x and y, both of which are variables. And the thing to remember here is that you can replace the variable, even though it's two separate variables, you can replace it with the same letter, which is exactly what we're going to do here. Now again, it doesn't matter what letter you replace it with. Whatever letter you happen to choose at the time is fine, but you have to do that instantiation. I'm going to use the letter G. So if you use A or C or F or whatever, that's fine too. But I'm going to use G for the purpose of demonstration here. So for every x, ax, then bx would become ag, then bg from line 1 through a universal instantiation. In line 2, we're going to replace the y with the g as well. So that becomes ag or not bg from line 2, universal instantiation. Okay. The important thing is that in order to be able to work with it using our rules of modus ponens, modus tollens, and all that fun stuff, that that you have to have the same instantiation letter being applied. So now we can just go on and begin to solve it. So this is, I think, the only one where it actually asked you, and I didn't realize this at the time, or I wouldn't have given it to you because I told you you wouldn't have to do these. But this one actually makes you use a couple of the replacement rules in able to do it. Because if you look at line 4, AG or not BG, you know that in order to get the material equivalence, basically you need if AG then BG, and if BG then AG. So you have to work basically on getting that. Well, the way you would do it, and if you got this, I'll be very proud of you. If you didn't, don't worry about it as long as you got the others. Number 5, I would just do one of those rare instances where it might help us to do a commutativity. So we just change the positions around there like that. And then, of course, not BG or AG is the equivalent of if BG then AG from material implication. Number 7, or line 7, we're just going to take the AG then BG and the BG then AG, stick them together using commutativity. Using conjunction. Just looking up. Shouldn't look up when I'm trying to do this. So that would be was lines 3 and 6 through conjunction. And so now, as we anticipated, if AG then BG and if BG then AG, basically conditional working both directions, is the material equivalence. So AG, if and only if BG, and then because it wants it in that form, you'll have to do a universal generalization. So we replace the universal variable of x, because that's the one they want, and we replace the g with the x, like that. And again, that's a universal generalization. So that one, I'm pretty sure, was the only one that asks you to use anything other than our basic 8 rules. So like I said, if you got that one, then you can be very proud of yourself. If you didn't, well, don't worry about it too badly. All right, number 5. All right, so we've got the universal x, ax, then bx or cx. Line 2, we have ag and not bg, therefore cg. All right, so looking at number 5 now, because we see in our second premise that G is the instantiation letter that's used, it tells us that when we change our X's in line 1, that we're going to want to make those G's. We're going to do a universal instantiation. And so this would become AG, then BG, or CG. Line 1, universal instantiation. And from here, we just go on to solve it like normal. So I would say, well, here, line 2, you've got AG and not BG. So we're going to simplify that to make it just AG. And so now you can see that 3 and 4 make a modus ponens. If AG, then BG or CG. AG, therefore CG or, BG or CG. So 3 and 4 modus ponens give us that. Now what we want to get is CG. We've got a wedge here, so if we can get a not BG, we can set up a disjunctive syllogism. Well, right up here on line 2, you've got AG and not BG. This time, this is the side we want, so we're going to do simplification again to keep this side, get rid of that one. So we end up with not BG from 2 through simplification. And so now there's our disjunctive syllogism, BG or CG, not BG, therefore CG. 5, 6, disjunctive syllogism. And it doesn't ask for anything other than that. It's the CG, so we're already in the form that they were looking for. So we can stop right at that point and consider number 5 to be done. Number 6. We have x, ax or bx, then cx. Line 2, ey, ay and dy. Therefore, ey, cy. Okay, so this is another one of those that's relatively easy, I guess, but they're trying to confuse you by making you use the x and the y. But like we saw before, you can replace the x and y with the same variable, or with the same instantiation, rather. So even though it's two separate variables, you can replace them with the same instantiation letter. So whatever letter you happen to want to use at the time, feel free to do. Let's use F. So AF or BF, then CF from line 1, universal instantiation. And then we'll do the same thing down here on line 2. We'll have AF and DF from line 2, universal, no, this was an existential, yeah. Existential instantiation, because it has the backwards E. Now from there, once you've got it in this form, it's just a simple matter of solving it like you would anything in propositional logic. So line 4, AF and DF, I'm going to simplify that to AF. Now what we want basically we're going to end up with the cy, so what we need is the cf. We need the consequent here. So to set up a modus ponens, we need the antecedent. We've already got the AF, we need AF or BF. So we take the AF from line 5, use addition. With addition, you can add anything you want into the equation, so I'm going to add a BF, just like that. And so now lines 3 and 6 give us our modus ponens. Again, if you need to visualize here, again, the antecedent is the square, the consequent is the circle, AF or BF is the square, so if square then circle, square therefore circle, which is CF. So you would derive CF from 3 and 6 through modus ponens. Now it wants it in that form with y as the variable, so on line 8 we're going to add in the existential variable EY, and we're going to replace the C with the Y. So that's a process that we've called the existential generalization. And so that one is done. Hopefully you're finding that these are not too hard. It's basically the same thing that we were doing with propositional logic, except that you have to do the instantiations and generalizations. And of course, remember that you're dealing with 2 letters rather than just 1. But other than that, the rules are basically the same. All right, so number 7, they're really trying to play with your mind a little bit because now they've used all 3 of the variables, x, y, and z. But again, doesn't matter how many, if they use 1, 2, or 3 of the variables that are there, you can translate those as the same when you do the instantiation. So, pick whatever letter you happen to want to use at the time, and go ahead and do that instantiation. Let's use M this time. So line 1, we'll make that JM, then KM and LM. From line 1, it's a universal instantiation. Then at line 4, we'll take line 2 and we'll do an existential instantiation. We'll get rid of the quantifier and we'll replace the y with that m. So we end up with not km from line 2 through existential instantiation. So now we just have to work this in order to try to get to the not jm, so we can translate it to not jz. All right, well, basically I can see right here there's a modus tollens. If jm, then km, not km, therefore not jm. So we just need to get rid of this lm, and we can do that easy enough through simplification. So we make line 3 jm, then km by using simplification. Again, anytime you've got a dot between 2 items, you can keep one side, throw away the other, and that's what we've done here. And so now it's a simple modus tollens. If jm, then km, not km, therefore not jm. There's 4 and 5 modus tollens. And so now it wants this form, so we're going to do an existential generalization. So we'll add in the existential quantifier with z as the variable, and we'll replace the instantiated letter m with the general letter of the z, just like that. And so that's an existential generalization, and that one's done too. Okay? So I said again, most of these pretty easy, pretty straightforward. Okay, number 8, we have x, ax then, bx, or cx. Line 2 is ex, ax and not cx. Therefore, ex, bx. Okay. So number 8, we're back to just using the one variable of x. Again, we can replace that with whatever letter we choose to replace it with. We haven't used p yet. Let's use p. That'll be fun. So on line 3, we'll take line 1 and we'll do a universal instantiation. Get rid of the quantifier, replace the x with the p, or whatever letter you chose to use. So line 1, universal instantiation. And then on line 2, we'll do an existential instantiation. We'll get rid of the quantifier and replace the x with, in this case, the p. So AP and not CP. Line 2, existential instantiation. And now we just go on and solve it. I would start by simplifying AP and not CP to just AP, because that way you've got lines 3 and 5 that make a modus ponens. If AP, then BP or CP. AP, therefore BP or CP, like that. So that's 3 and 5 modus ponens. All right. Now what we want basically is the BP, so we can translate it into the BX. So I've got it here in a disjunctive, BP or CP. So what I need if I want the BP is not CP. Now, if you wanted to put in that rule of commutativity here, you're welcome to do that, or you can hand wave it like I usually do. Either way is fine. But basically all you really need is to go back to line 4. You've got AP and not CP. Not CP from 4 through simplification, right? We're keeping one side, getting rid of the other. And so now it's either BP or it's CP. It's not CP, so it has to be BP. So that's 6-7 is a disjunctive syllogism. And then, of course, they wanted this existential form. So we're going to do an existential generalization now on line 8. And so we'll add the existential quantifier, the e with the backwards e with the x, and replace the p with the x like that. And that's an existential generalization. And looks like we've proven number 8 to be valid as well. Number 9. Number 9, we have x, ax, then bx. 2, we have am and an. Therefore, bm or bn. All right. No, bm. No, that was bm and bn, not or. Okay, that makes more sense. All right. So in this one might be a little bit tricky too, because you see that there are two instantiation letters, AM and AN. Well, the thing is that you can, just as you can use the same instantiation letter for multiple variables, you could also potentially reuse variables. I mean, that's the whole nature of what a variable is to imply that it is something that can be replaced by multiple things. So that's what we're going to do in this particular case. So line 1, I've got for every x, if x is an a, then x is a b. I'm going to replace it first with the m. So we'll make that am, then bm, line 1, universal instantiation. Then I will simplify line 2. am and an becomes am, line 2 through simplification. And so here is modus ponens. If am, then bm, am, therefore bm. Right, 3, 4, modus ponens. And that's the first half of what we need. But now we need the bn. So we'll go back to line 1 again, and we'll do another instantiation, this time replacing the x with an n. So an, then bn, from line 1 as a universal instantiation. And then we'll go back to line 2. We've got am and an. So we'll use simplification to keep the an and get rid of the am this time. So we'll have an from line 2 through simplification. And then, once again, it's a simple modus ponens. If an, then bn, an, therefore bn. 6 and 7 modus ponens. And finally, what we wanted is the bm and bn. So you've got bm on line 5, bn on line 6. We're going to take those and stick them together using conjunction. So that was 5 and 8 through conjunction. And there you go, there's number 9. And so now we come to the last one, which is number 10. We have for every x, ax, then bx. Line 2, we have am or an. And at line conclusion, bm or bn. Okay, so this one looks similar to the one we just did in that it has both the m and the n. So just like the other one, you are going to need to instantiate twice. So we'll start off here by taking line 1 and we'll do a universal instantiation using the m. So this becomes am, then bm from line 1. That's a universal instantiation. And then we'll go back and do the same thing using the n. So we'll make that an, then bn from line 1. Again, universal instantiation. Again, because it's a variable, it can stand for any letter. So you're just allowing it to stand for those two. Now, what you'll notice is that we have two conditional statements here. The premise that we have, am or an, are the two antecedents joined by the wedge. The conclusion we want to reach, bm or bn, are the two consequents joined by the wedge, which means we're basically looking for a constructive dilemma. So to set up constructive dilemma in its proper form, we'll just need to do a conjunction on lines 3 and 4. So that'll be if am, then bm, and if an, then bn, lines 3 and 4 conjunction. And then, just as we saw, there's your two conditionals joined by the dot, if am, then bm, and if an, then bn. Your second premise, am or an, the two antecedents joined by the wedge, therefore bm or bn, the 2 consequents joined by the wedge. So 2 and 5 through constructive dilemma yield the answer that we wanted to reach. Okay, so that proves that one also as being valid. All right, so that was basically it. If you guys checked through that and did well with it and have no questions, then you should be in good shape to go ahead and take the exam, which again, remember, has to be completed by midnight Wednesday this week. And if you didn't, then shoot me an email or stop in to the live stream on Wednesday morning at 9:30, and I'll answer any questions or go over anything you need me to go over at that point. But in the meanwhile, wish you best of luck, and we'll talk to you later.